Coming into the video of today's, we have discussed already about some terminologies of the artificial neural network. In this video we will be discussing about the Herb network. Herb network means, according to the Herb rule, the weight vector is found to increase the proportionality of to the product of the input and the learning signal. In this network, weights vector will be founded out. Okay, weights vector will be recognized to increase the proportionality of the product. Okay, the proportionality of the product that has to be increased in this hub network, we will be checking the weight vector or finding the weight vector. The learning signal is equal to the neurons output. Whatever learning signal will be always equal to the neural output. Okay, Herb learning, if two interconnected neurons are on simultaneously, then the weights associated to these neurons can be increased by the modification made in the synaptic gap. Okay, if the neurons which are interconnected are on, then the weight associated to that neurons can be increased by the modification of the gap. What is the modification formula means? Weight of the new is equals to weight of old plus xi. This is how we can modify the nodes. Okay, weight will be associated to the neurons using this formula. Herb rule has suited for the bipolar data. When the Herb rule will be suitable, when there is a bipolar data, then the comparing to the binary data, then the Herb rule will be used. There are two conditions, okay, in the Herb rule. A training pair in which an input unit is on. When the input unit is on and the target value is off, this is the one of the condition. In training pair, whenever there is a training pair, in that training pair, input unit should be on, target value should be off. This is one condition. Coming into the next condition, the both input unit and the target value should be off. These are the two conditions of the Herb network. After defining the Herb network, we need to write an algorithm to that. Coming into that algorithm, this is the first step. What is the first step? We need to initialize the weights. The weight should be initialized in such a way that wi is equals to 0 for I is equals to 1 to n. Okay, where every weight, the weight of the network will be starting with the 0 only, where n may be the total number of input neurons. These are the input neurons of the network. The second step is like, we need to perform the third and fifth step for each input vector and the target output pair. We need to always perform the third and fifth step to give the performance between the input vector and the output vector. What are the two steps means? We need to give the input vector activation sets, and after the input vector activation, then the output vector activation will be done. And how the input vector activation will be done of the input layer means xi, which is equals to si, where I is from the 1 to n, that is number of networks. After the input and output, we need to adjust the weight and bias. Okay, we need to adjust the weight and the bias. This is what is the algorithm. The first step, we should be initialized. Second step, we have to perform the third step and the fifth step if the each input training vector and the target output pair are there. In the third step, first we have to take the input unit activation, and fourth step output activation. After these two, next step we will be adjusting the weight and the bias. Coming into the flow diagram, look at that. First we are starting, okay, then after we are being initializing the weights, that is weight is equals to 0. We are initializing that for each s is r, s is to r, if this condition is being false, then we gonna stop the process. If this condition is yes, then we have to activate the input unit, that is xi is equals to si. Then we have to even activate the output unit, that is y is equals to t. After activation of input and output, we have to update the weight and the bias. What is the formula of updating the weight? Means wi is equals to weight of old plus xy. This is a weight. This is how we can update the weight. How can we update the bias? Means bias of new is equals to bias of old plus y. This is how we will be updating the bias. First we need to initialize. We should check whether the condition is approved. If the condition is not approved, we're going to stop the process. If the condition is approved, we will be getting into the next step, that is activation of inputs, activation of outputs. After the activating, we need to update the weight and the bias. Then we will be stopping the process. Let's look into the example of the Hebb network. Let us construct an artificial neural network by using the Hebb algorithm for AND gate. Okay, this is what is a question. Okay, these are the inputs which are we are given, and after the inputs given, the weight will be getting into the bias. Okay, bias will be applied. Okay, bias will be applied to the output and the weights will be given. Now here we are gonna have xi, y, x2 and y, x1, x2 and y. These are the input one and this will be the output. The first step, the first input w1, that is we need to initialize the weight and bias as 0, right? In the first step, here we are gonna initialize the weight and the bias which is equals to 0. What is the updation for the weight? W new is equals to W of old plus X I Y, no? Okay, we will be applying that. Look at this, W new is equals to W old plus XY. What is the W1 old? Look at the weight of this. W old is X1, right? Sorry, what is the old weight? It is a 0. We are initializing the 0, right? We will be writing 0. XY. What is the X1? 1. And what is the Y value? 1. 1 into 1, 1. 0 plus 1 is 1. This is the first new weight, updated weight. In the second one, W2 old plus X2 Y2. What is the W2 old? We have initialized as 0, right? That we have been writing here. What is X2? 1. And what is the Y1? Okay, 1 into 1, 1. 0 plus 1, 1. This is the second updated weight. After updating the weights, what is the next step we have to do? It's a bias. Bias means new bias is equals to old bias plus y. What is the old bias that we have initialized? Is 0, right? We have to write the 0 here. And what is the y value? Here we are not using the xy. We are only using the y. Whereas in the updating of weights, we will be using xy. Okay, what is the y value? 1. So 0 plus 1 is equals to 1. This is the first input where the weights and bias has been updated. So these will be the outputs to the next input. Look at them. What is the W1? In the previous we got the 1. In the what is the W2? We got 1. And bias will be also 1. Okay, we need to update the weights right now. What is the weight updating? W1 new is equals to W1 old plus XY, right? What is the old one? 1. We written here 1. And X and Y means, what is the next X and Y? X means 1. And what is the Y value? Minus 1, right? We are writing here 1 into minus 1. 1 into minus 1 is minus 1. Whole thing gets 0. And coming into the W2, what is the W2 old? Means 1. And X2 Y. What is the X2 minus 1 and Y also minus 1. Minus 1 into minus 1 is plus 1. 1 plus 1 is 2. This is the updated weight. Next, coming into the bias. After updating these two weights, we have to update the bias, right? B new is equals to B old plus Y. What is the old one? 1 plus y means here it is minus 1. We have to write here, okay, 1. We have to write here 1 plus 1 minus 1, everything gets 0. Next, this w weight and this bias will be the input to the next. Okay, for the third one, w1 that is here 0, w2 that is 2, bias 0. Okay, now we need to update the weights. What is the updation? W1 new is equals to W1 old plus XY. What is the W1 old? We got here 0. Next, XY. What is the X value? Minus 1. What is the Y value? Minus 1. We are writing minus 1 into minus 1, which is plus 1. This is the updated one. Next, W2 old plus X2 Y2. What is the W2? 2. We should write here 2. What is the X2Y? X2Y is a 1 and minus 1. We are writing, okay, 1 minus 1. 1 into minus 1 is minus 1. Minus 1 plus 2, that is 2 plus minus 1 is 1. Okay, the weight has been updated. After updation of these two weights, we need to update the bias, right? B new is equals to B old plus Y. That is, what is a B old? 0. What is the Y value? Look at here. What is the Y value? That is minus 1. We have to write here minus 1. 0 plus minus 1 is minus 1. Next, fourth input. What will be the weights that will be getting is W1 will be 1, W2 will be 1, and bias is minus 1. Look at that. W1 new is equals to W old plus XY. What is the W1 old? We got here 1. And XY. What is the X value here? Minus 1. And Y value is also minus 1. We are writing here minus 1 into minus 1, which is plus 1. Plus 1 plus is equals to 2. Next, we are updating the second weight. W2 old plus X2Y. What is the X2 here? Minus 1 and Y is minus 1. Minus 1 into minus 1 is plus 2. Okay, plus 1, plus 2. After updating these two weights, we need to update the bias, right? B old plus Y. What is the B old? Minus 1. We are writing minus 1. What is the Y value? As I said here, minus 1, right? We will be writing minus 1. Minus 1 plus minus 1 is minus 2. What are the weights we have got? 2, bias is minus 2. So summation of x1 y1 plus x2 y w2 plus bias into 1. This is the summation thing we have to write to get the actual output. In the previous one, look at here, x1 is 2, next w1 is 2, x2 is minus 2, and w2 sorry, x1 y1. First, in the first thing, let's write the table again here. What is a table? This is what is the table which has been given to find the summation, that is actual output. This is the formula to find the actual output. What is that? x1 is 1 into w1, that is 2. 1 into 2 is 2. Okay, next x2 is 1, w2 is 1, that is answer will be 1 into 2, 2. B is like minus 2, and y is what is the y? That is 1. Okay, that we have to use it as minus 2. Minus 2 plus 2 will cancel. We will be getting the actual output as summation will be like 2. This is the summation value. Next, the x1 is 1 and w1 is 2. 1 into 2 is 2. W2 is 2 and x1 is minus 2. Minus 1 into 2 is minus 2. B is minus 2 into 1 is minus 2 only, right? Minus 2. This is the next summation value. This is how we will be calculating the summation values, and those summations values will be written in this. After that, we already have the actual output. Y is what is the actual output. This is the actual output. In this way, we can construct an hub network for the AND gate.